Hi there. For this video, we'll be talking about the difference of two squares. To do this, let us first recall that from a previous video, we know that a plus b times a minus b will give us a squared minus b squared. And this is from the idea of sum and difference of two squares. Now, if we do the reverse, we will have a squared minus b squared going to a plus b times a minus b. And this is the idea on the difference of two squares factoring method. So let's try it out in an example. Let's have x squared minus 64. Now the key in applying this method is to first check this first term out here if it is a perfect square. Clearly it is a perfect square since square root of x squared is equal to x. And the same for the last term. If we check the last term, we can see that the square root of 64 is equal to 8. After that, we check if the operation is subtraction. Since the operation is subtraction, we can apply the difference of two squares method. So factoring x squared minus 64 is simply x plus 8 times x minus 8. And this is the factored form. Let's try out this next example. If we have 4y squared minus 25. Again, we check first the first and the last term. So the first term, if we get its square root, we will get 2y. Since square root of 4 is 2, and square root of y squared is y. For 25, note that the square root of 25 is equal to 5. So these two are perfect square. Lastly, since the operation is subtraction, then we know that we can apply the difference of two squares method. So this one out here is simply equal to the square root of the first term, which is 2y, plus the square root of the last term, which is 5, times the same binomial, but with a subtraction operation. And so that is how we factor out these binomials. Let's have this third example. If we have 3a squared minus 12, at first glance, we can assume that this one out here doesn't seem to be a perfect square since the square root of 3a squared is equal to square root of 3 times square root of a squared, which is equal to square root of 3 times 8. And this isn't a perfect square since we still have a square root out here. But observe that if we apply the GCM, we can write this one as 3 times a squared minus 3 times 4. Since there is a factor of 3 on both, then we can write this one as 3 times a squared minus 4. And so we can focus instead on this binomial inside. Observe that a squared is a perfect square since the square root of a squared is equal to 8. Also, 4 is a perfect square since we know that the square root of 4 is equal to 2. Since we have the subtraction operation here, we can apply the difference of two squares. So this one out here is equal to 3 times square root of the first term, which is a, plus square root of the last term, which is 2, and the same binomial but with a subtraction operation. And so this is the factored form of this binomial. So as you can see, we can actually integrate all the factoring methods that we have so far into one problem. Let's have our fourth example. If we have b raised to 4 minus 16, first, observe that b raised to 4 is a perfect square since b raised to 4 square root will give us b squared. 16 is also a perfect square since square root of 16 is equal to 4. And so, I forgot, but also the operation is subtraction. So we can clearly use the difference of two squares. So this one will be equal to square root of the first term, which is b squared, plus the square root of the second term, which is 4 times b squared minus 4. Now observe that we can actually still factor this one out, since this one out here is a perfect square. I mean, the first term is a perfect square and the second term is a perfect square. So we can still apply the difference of two squares. How about for this one? Can we apply the difference of two squares out here? Yes, the first term is a perfect square and the second term is a perfect square, but the operation is addition, so we can't apply it. But note that you can actually write this one as b squared minus negative 4. However, if you apply the difference of two squares method, we will actually have a factor of a complex number, but we are not dealing with that still, since we are focused more on real numbers and most specifically integers. So we focus on this one. Note that b squared is a perfect square since the square root of b squared is equal to b. Also, 4 is a perfect square since square root of 4 is equal to 2. And since the operation out here is subtraction, we can conclude that this one is equal to, first, we copy this one. So we'll have b squared plus 4, and factoring the b squared minus 4, we will have square root of the first term, which is b, plus square root of the second term, which is 2, times the same binomial but with subtraction. And so this is the factored form of this binomial. Let's have one last example. If we have x plus y squared minus x minus y squared. Oops. Right here. Now observe that one method that we can do is we can simplify this one by applying square root of a binomial first. But actually, we can apply the difference of two squares in this one. First, note that if we treat this one as a single variable, say this is a, and we say this is b, then it is of the same form as a squared minus b squared, which we know to be, in factored form, is a plus b times a minus b. So we can write this one as a, in this case, is x plus y, plus b, in this case, is x minus y, times a minus b, which is x minus 1. And then we can simplify the expressions inside the parentheses. So in the first one, we will have x plus x will give us 2x, and y minus y, that one will cancel out. And then for the next one, we have x minus x will cancel out, and y minus negative y will give us 2y. So this one out here will be 2y. Simplifying, this will give us 2 times 2 is 4 times x and times y. So that is the final answer. So that is how we use difference of two squares. I hope you learned a lot from this video, and feel free to comment down any suggestions and recommendations that you have for the future videos. And so that's it, and that is all for this video.